Student, today we are going to discuss about class 10 physics example problem. It's from the electricity chapter. We are going to discuss all example problems. There are 12 example problems there. We are going to discuss all the problems. Okay, first we'll start from the first problem. 12th chapter first problem, it is a electricity problem we are going to discuss. Okay, so in this question, no, current is given as a 0.5 ampere. Okay, it is a example problem. 12th chapter first problem, current is given 0.5. Okay, time is given as a 10 minutes. Okay, time is given 10 minutes. They ask you to calculate what is the charge. Okay, current is equal to charge per unit time. Just to modify this, charge is equal to current into time. So what is the current here? 0.5. So charge is equal to current into time. Current is 0.5. What is time? No, 10 minutes. Okay, 10 minutes, always the problem you should do with the SI unit. What is SI unit? MKS system, meter, kilogram, second. Minutes to second you should do. Okay, 1 minute how many second? 60 seconds. So 10 into 60 seconds. Okay, this will be 600. Instead of writing off 0.5, you can write as a off into 600. Okay, we are finding the charge. Unit of charge is coulombs. Okay, this get cancelled. Charge is going to give us a 300 coulombs. Okay, now example second problem, NCERT second problem. Okay, it is a example 12th chapter second problem. Same electricity problem only we are going to discuss. Okay, say volt and charge is given. They asked about the work done. Voltage is given as a 12 volt. Charge is given as a 2 coulombs. Okay, they asked work done. Work done is equal to dash. We know voltage is equal to work done by charge. Okay, charge, if you are taken this side, work done is equal to volt into charge. Volt is how much? 12. Charge is how much? 2. So 24. Okay, that's called work done. What is unit of work done? Joules. Okay, now I am going to do with the third problem. Okay, NCERT example problem. It's a third problem right now we are going to see. Okay, example 12th chapter third problem. 12th chapter third problem. Okay, there are two questions is given, A and B. Okay, both we are going to solve. In this question there are two things is there. Question A, 220 volt 1200 ohms, B 220 volt 100 ohms. Okay, so first sec A, voltage is 220, resistance is 1200 ohms. They asked about here current, ohms law only. B question, voltage is 220, resistance is 100 ohms. They asked about current. Okay, these are the both the question they asked. Okay, now first question, A question. A, voltage is 220, resistance is 1200, current is question mark. I is equal to V by R. According to Ohm's law, V is equal to IR, I is equal to V by R. What is V? 220. What is R? 1200. 0, 0 get cancelled. 22 divided by 120. 22 divided by 120. 0.0. 120 will be one time. Again 0, 0, 1 will be there. Okay. So, see here. Just one more 0 you can include. 120 into 8 time will check. 0, 6, 1, 9, 960. Okay, 8 time. It will go like that. We can stop here. 2 decimal is enough. 0.18 ampere as a current for first condition. Okay, second condition, no. Same. Right now we are in the third problem. Second current, V by R. V is how much? 220. R is how much? 100. Cancel, cancel. 22 divided by 10, 2.2 ampere. Okay. Then I am going to do with the third question, fourth question. Okay. Example problem, 12th chapter, fourth problem. We'll see what is given. Current is 4 ampere. Voltage is 60 volt. Okay. 60 volt. Okay. Now they are increasing the voltage as a 120 volt. Okay, now what is the current will be flow? At this situation only they want current. See, this is a question we are going to see. The voltage, no, when they applied 60 volt, 4 ampere current is flowing. Okay, when they are applying 120, what is the current? That is a question. For both the condition, resistance will be the same. The resistance of the wire is going to be constant. Okay, This two, no. Some resistance is created, no. Same resistance you can use here also. The second situation only they asked about the current. First, the solution I am going to see. First I am going to find resistance. R is equal to V by I. V is how much? 60. I is how much? 4. So if you are cancelling two tables, 30 divided by 2. Exactly 30 divided by 2, 15 ohms. Resistance is 15 ohms. I got with the first situation. Okay. Now voltage is applied 60 volt to, they are increasing as a 120 volt. Okay. Resistance will be same for second condition. Now I is equal to V by R. Now what is V? V is 120. R will be same. Whatever condition, R will be same. R is going to be a 15. Okay. So 5 tables 3. 5 tables no 2 is going to be a 4. 24 divided by 3. 24 3 tables how many times will get? 8 ampere. Finally current will get as a 8 ampere. Okay. 4 problems is over. Right now NCERT example 12th chapter 5th problem we are going to see. Example 12th chapter 5th problem. Okay. It is a resistivity problem. They asked you to refer the tabular column. So these are the data is given. They asked about the resistivity. Okay. Resistance is given as a 26. Dia is given as a 0.3 millimeter. Length is given as a 1 meter. Okay. Now resistivity is a question mark. They asked you to tell the what material it is. Okay. This is a question they asked in previously CBSE also, CBSE board exam also they asked. Okay. R is equal to rho L by A. This is a formula. I want this one just to modify the formula. R A by L is equal to rho. This only we are going to find. Resistivity. Resistivity is equal to resistance. Resistance times of 26. Area we can call as a pi R square divided by L. What is pi? 22 by 7. Radius if you want, dia divided by 2. What is dia? 3 millimeter. Already I told you problem you should do SI unit. Millimeter to meter 10 power minus 3. 0.3 into 10 power minus 3 meter. Okay. Diameter to radius if you want. Diameter divided by 2 will give us a radius. Okay. Now resistivity is equal to 26 into 22 by 7 pi value. Radius is 0.3 divided by 2. Millimeter to meter 10 power minus 3 whole square divided by 1. Now we are going to calculate this problem. Denominator length is 1 only. No need to use that one. Okay. Then 26 into 22 by 2. 22 by 7. Sorry. 22 by 7 into 0.3 divided by 2 into 0.3 divided by 2 into 10 power minus 3 into 10 power minus 3. Minus 3 minus 3. Minus 6, 10 power minus 6. Okay. 2 tables 22 will be 11. Okay. 2 tables 26 will be 13. Okay. Just you can cancel. Then 13 into 11 into 0.3 into 0.3, 0.9. 339. 2 decimal is there. Into 10 power minus 6 divided by 7. Okay. So now what I am going to do now? Just multiplication. This and this. I want to make it this as a round number. Numerator 100, denominator 100, you can multiple and you can divide, because decimal if you are removing, calculation will be easy. 13 into 11 into 9 divided by 700 into 10 power minus 6. So 9 into 11, 99. 99 into 13 divided by 700. Okay. So 13 into 99. 99 into 30, 13 or 13 into 99. What we can get now? It's a very simple calculation. See here. 99 into 30. 9 3s are 27, 27, 28, 29. Again 99, 7, 8, 1, 12. 1, 2, 8, 7. Into 10 power minus 6 will be there. 1, 2, 1, 2, 8, 7 divided by 700. Okay. Now, just division with this will give the answer 10 power minus 6. Okay. Division for this two number will give the answer. Now I am going to divide both the numbers. See here is equal to 1287 divided by 700 into 10 power minus 6. Okay. So it's going to be 1287 700. First is the one time. 700 is one time. Okay. 785.0 0. Now, the second thing, no, I'll get us 5600, which is going to give us a 8 times. Remaining 0, 7, 2, 0, you can take it here. Okay. The close value, it's going to be 2100 means 3 times will come. Otherwise, next value if you are going now, the round off will be 1.84 into 10 power minus 6. Otherwise, you can write as according to the calculation 1.83 into 10 power minus 6. Minus 6. Both are correct only. Okay. So now what is a unit? No. It is a resistivity. Okay. Resistivity. No. Resistance area by length. Ohm meter square divided by meter. So it is going to give us a ohm meter. Ohm meter. Okay. Still the problem is not over. They asked you to find which material it is. Okay, you can refer the tabular column. See here, I am going to refer the tabular column. Okay, 1.83, 1.8483, no. Manganese. Okay, this is an example. Okay, you can refer the tabular column and give the answer. Okay, next one, it is an example, 11th chapter, 5th problem we are going to learn. Okay, it's a very simple problem. 6th problem. Example problem, 11th chapter, 6th problem. See here, the length is become as of, area become double. What is the new resistivity? This is the question we are going to solve. Okay, so resistance of the wire is 4 ohms. Okay, it's going to be wire resistance if you want, R is equal to rho L by A. This is the formula. Now new situation, no, it is called old resistance 4 ohms. Length of area double, length of area double. Okay, same wire, length of area double. Resistance of new is going to be resistance length of area double. 2 to 4 will get. The resistance new is going to be rho L by 4A. What is rho L? Rho L by A. Rho by L by A, which is going to give us a old resistance, which is going to give us a 4 ohms. Okay. So now R new is going to be R old divided by 4. Very simple. I used this equation. It is a old resistance. Length become area become double. Just I modified the equation. Now 4 I got extra compared to the previous equation and this equation. According to equation 1 and equation 2 you can compare. You will get 4 as extra. Okay, R old is 4. Now 4 times the resistance will decrease, 4 will get cancelled. The answer for this value is going to be 1 ohms. Okay. Now the same NCERT example, 11th chapter, 7th problem we are going to do. Okay. The resistance in series problem we are going to discuss. Okay. If you like my channel, please subscribe. If you want more example exercise problem, means you can go and see my playlist, 12th chapter, 7th problem. Okay. Two resistance in series. Okay, 4 ohms and 24 ohms in series. This is a problem we are going to discuss. The voltage I applied as a 6 volt. Okay, same, it is a 4 ohms. The bulb is 20 ohms, which is given in the question. Okay, they applied the battery as a 6 volt, plus minus battery as a 6 volt. Now we are going to calculate what is the total resistance. The current is total, the question is total resistance, total current and voltage on each, V1 voltage and V2 voltage. These are the question. V1 voltage here, V2 voltage here. We'll find all the answer. Okay. Now, the total resistance. Resistance in series RS is equal to R1 plus R2. What is R1? 4 ohms. What is R2? 20. 4 plus 20 will have 24 ohms. R total in this problem 24 ohms. Okay, this answer 24. Now I total is equal to V total divided by R total. According to Ohm's law, V is equal to IR. I is equal to V by R. V is how much? 6. R is how much? It's going to be 24. 1 divided by 4. Just cancel with 6 table. That's going to be 1 divided by 4, 0.25 ampere. Current is 0.25 ampere. Okay. Current in series constant, 0.25, 0.25, 0.25. Same current only, it's flowing. Okay. Now V1 IR1, V2 IR2. V1 if you want IR1. V2 if you want IR2. Why is the current is same? In series current is constant. Okay. V1 is 1 by 4. 1 by 4 into 4. 4 get cancel. It is called 1 volt. Again, I is 1 by 4. R is how much? No, 20. R2 is 20. So this is going to give us a 5. So 5 volt. Okay. You can cross check the problem. This together will give us a total voltage. 1 plus 5 will give 6 volt, which is applied voltage, 6 volt. Okay. This answer 24. This answer 1 by 4. This answer 1 volt. This answer 5 volt. Okay. Now we are going to learn with the 12th chapter 8th problem. If you like my channel, please subscribe. Okay. Same electricity example problem, 12th chapter 8th problem. Now parallel problem we are going to discuss. Okay. In parallel, no voltage remain constant. 5, 10, 30 ohms is connected in parallel with 12 volt battery. Okay, I will draw here connection 5 ohms, 10 ohms and 30 ohms. These are the three resistances connected in parallel with 12 volt battery. With 12 volt battery. 12 volt, 5, 10, 30 ohms. Okay. Now we are going to find R total. Okay. And I total. And I1, I2, I3. These are the question is asked here. Okay. How to find I1, I2, I3? In parallel, voltage remains constant. That already I told you. Series current is constant. Parallel volt is constant. That definitely you need to know this concept. Okay. Otherwise, you are not able to solve the problem. See, first we will find R total. 1 by Rp. Parallel formula. 1 by Rp. 1 by 5 plus 1 by 10 plus 1 by 30. Make common LCM. Okay. So here just multiple with 3. 3 into 3. Denominator 30. Here 6. Denominator 30. So 6 by 30 plus 3 by 30 plus 1 by 30. Why sir you are doing like this? Because I am making as a LCM as a common. 30. 6 plus 3 plus 1. 1 by Rp. So 1 by Rp is equal to 3 by 10. Sorry, 3 by 30. Sorry, 10 by 30. 0 get cancel. 1 by Rp is equal to 1 by 3. Rp is how much? Flip the equation. 3 ohms. Rp I got. Okay. This is called R total. If you want I total is equal to V total divided by R total. What is V? 12. What is R total or 3? So, the total current is 4 ampere. Okay. This I got as a 3 ohms. This I got as a 4 ampere. Now, I1, I2, I3. I1 here, I2 here, I3 here. In series, current is not a constant. Voltage is sorry. In parallel, voltage is constant. Current is not constant. If you want I1, V by R1. I2, V by R2. I3, V by R3. What is V? 12. 12 by 5. 12 by 10. 12 by 30. 12 by 10 will be very simple. 1.2. 12 by 5 no. It's going to be 12. 5, 10, 2 times. Again 2 will be there. 0.0. 20 will be 4 times. Okay. 2.4 ampere. 1.2 ampere. Okay. Now I3 no. I'm going to find what is I3. I3 is going to be 12 divided by 30. 2 tables. 6 divided by 5. 6. It's going to be 2 tables. 6. 2 tables 15. Again 3 tables. Okay. 3 tables 2 divided by 5. 2 inside, 5 outside. Okay, 0.0, 20 will be 4 times. 20 will be 4 times. 0.4 ampere. Okay. Now this problem also you can cross check. I total is equal to I1 plus I2 plus I3. All together will give us I. 2.4 plus 1.2 plus 0.4 will give us a 4 ampere as a current I total. Just we cross-checked, we did correct or wrong. Okay. Now we are going to discuss about 12th chapter, 9th problem, NCERT example problem. Okay. So this is a circuit we are going to discuss. Don't take it all 5 in a parallel. This 2 separate, this 2 separate. Now we'll see how to do with the solution. Okay. It is an example problem, 12th chapter, 9th problem. Okay. Circuit is like this. R1, R2. Here ammeter they connected. Here 3 resistor is there. 1, 2, 3. Okay, now here they connected as a voltage, voltmeter. What I am going to do now? Just I am going to find this 2 solution, then this 3 solution. First we will find this 2 solution. Okay, what is this 2 now? It's going to be R 10, 40. This is 30, 20, 60. Voltage is applied with 12 volt battery, plus or minus, plus minus. Okay, first we will solve this one. It is easy only, both are parallel, 10 and 40. 10 and 40 in parallel, 10, 40. For parallel formula, 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by 10 plus 1 by 40. Just cross multiplication you can do, otherwise you can multiply with 4. Because common LCM will get 4 by 10, sorry 4 by 40, 1 by 40, which is going to be get 1 by Rp. So 40 will be common LCM, 4 plus 1 will be 5, 1 by Rp. What is Rp? Which is going to give us a 8 Rp. Flip the equation, will get as a 8 ohms. This solution, no, 8 ohms I got. Now we'll do this solution next. Okay. So 3 resistance in parallel. 3 resistance. 1 by Rp is equal to, we'll take it dash this one, 1 by R1 plus 1 by R3, 1 by R4 plus 1 by R5. Total of 5 resistance is there, no. That's the reason I am taken like this. Okay. What is R3? R3 is 30, 20, 60. 30, 20, 60. 1 by Rp. Okay. So make it common LCM as a 60. If you want 60 here, multiple with 2. If you want 60 here, multiple with 3. So 1 by Rp is equal to 2 by 60 plus 3 by 60 plus 1 by 60. So 2 plus 3 plus 1, 6. So 1 by Rp is equal to 6 by 60. So flip the equation. Rp is equal to 60 by 6. So which is give as a 10 ohms. Okay. This answer 10 ohms. This answer 8 ohms. Now we'll do this 2 in a series. Okay. How sir this 2 in a series? That also we'll learn. Here will be 10 ohms. Okay. Here ammeter is there. Here will be, sorry, this is 10 ohms. This is 8 ohms. Okay. Whenever connection you got like this, no, it is series only. Don't see like this. Okay. So total resistance is equal to 8 plus 10. Series you can directly add 8 plus 10, the total resistance of this circuit. Our total is called 18 ohms. What is V? It's going to be 12 volt. Now I is equal to V by R. V is how much? 12. R is how much? It's going to be a 18. 3 tables, 6 tables. Okay, 6 tables 2 times. It is 3 times. 2 by 3. 2 by 3. 18 will be 6 times. Again 2 will get 0. 18. 6, 6, 6, 6 bar will go. So you can write as I as 0.67 ampere. Okay. Now NCRT example problem. The next problem, 10th problem we are going to do. 10th problem I will do when end of the class. Okay, now I will do the 11th problem. Okay, this is a problem we are going to discuss. Okay, 10th problem I will do last. Okay, 11th problem. Energy is given, resistance is given, time is each second is given, 1 second. Okay, they want what is a current and what is a voltage. Okay, so energy is 100 joules. Resistance is 4 ohms. Okay, now the time is each second, no, 1 second. Okay, they want what is the current and what is the voltage. Okay, I use a formula, Joule's law of heating, E is equal to I square RT. I square RT. Why sir you are choosing this formula? Because I know what is E, what is I, what is T, except current. Okay, 100 is equal to I square 4 into 1. Okay, this you can bring as a denominator. 100 divided by 4 is equal to I square, which is going to give us a 25. 25 is equal to I square. I is equal to root of 25, which is going to give us a 5 ampere. The next one, V they asked. V is equal to IR. What is I? 5. What is R? 4. 5 4s are will have 20 volt. Okay. It is the next problem, 12th chapter. 12th problem we are going to do. Okay, it's very simple problem, 12th example problem, 12th chapter, 12th problem. Okay, see, voltage is given, current is given, they asked about the power. V is 220, I is 0.5, so V is 220 a volt, I is 0.5 ampere. Now power is equal to question mark, power is VI, V is 220, I is 0.5, you can write off. Okay, this is going to give us a 110 power. No, we are finding power is 110, power unit will be what? W. Okay, you can use the formula, energy is I square RT VIT V square by R into T. This is the energy formula. If you want power, power is equal to I square R, just remove the time, VI is equal to V square by R. Whenever based on the problem, you can choose from this formula. Okay, then 13th problem, example 12th chapter, 13th problem. Okay, it's a electrical cost problem. So see here, now I'm going to discuss with the problem, 13th problem. Power is 400 watt, time is 8 hour per day. Okay, so power is given 400 watt, time is given 8 hours per day. It is an electric cost problem. Cost, no, rupees per year, commercial unit 3 rupees. They want in that month 30 days. Okay, what is the electric bill? So if you want energy, energy is equal to power into time. Power is equal to energy by time. Energy is equal to power into time. What is power? 400. What is time? 8. Okay, so this two multiplication, watt into hour, watt hour we can get. So only I got as a for 1 day. 30 days means into 30. So energy is equal to 400 into 8 into 30. This is for watt hour in a 1 day, in a single day. Okay, so 4 into 8 into 3 into 1000 I am taken separately, watt hour. If you want to convert watt hour to the kilowatt hour, divided by 1000. So if you want to always the commercial unit, no, you have to do with the kWh. Okay, energy in a kilowatt hour, 483 into 1000 divided by 1000. Unit, no, watt hour is converted as a kilowatt hour. Cancel. So remaining as it is will be there, 483. Energy is equal to 4 into 8 into 3 kilowatt hour. 1 kWh is 3 rupees. So this many kWh is how many rupees? If you want cost of electric bill, 4 into 8 into 3 into 3. Why sir 3? Because of 3 rupees. This many kWh is happen into 3. Okay, now we can multiple. It's going to be a 8 4 32. It's 9. Okay, 32 into 9. That is the cost of that particular month. Okay. So finally the cost of the electric bill is going to be 288 rupees. Hello student, today we are going to discuss 12th chapter, 10th problem. It's the last problem in this chapter. Okay, there are two conditions. Power is 840 watt. Okay, and 220 volt. They asked about current and resistance for first condition. Second condition, no, same 360 watt, 220 volt. Okay, they want what is the resistance and current. First we will do this one. Okay, so power is equal to how much? No, 840. Current voltage is 220. Now we will find what is the current. P is equal to VI. Already I told you what is the formula. This if you are bringing here, I is equal to P by V. What is P? 840. What is I? 220. 0 get cancelled. 84 divided by 22. So how many times? The first thing 66 will be 3 times. Remaining, no, 7 4 again here 8 1 0. It's going to be 22 tables. No, how much time will get? No, 8 times. 22 into 8 6 1 again 17 will get 176 will be 8 times. Again 4 will be there, 0, 22 will be 1. So current is equal to 3.81 ampere. Now I want what is A resistance R is equal to V by I. What is V? 220. What is I? 3.81. 3.81. Now the calculation we should do. Numerator 100, denominator 100, you can multiple to bring the round number. Okay, just a calculation I am doing. So R is equal to 220030 divided by 381. Just direct division only. 22000381. Okay, the first thing 5 times I'll get. Okay, so 5 into this much 381. No, what I can get? 1905. Next, the subtraction of this it's going to be a 5 9 2 the 0, the another 0 I am bringing here. Okay, this one no, 2667 I will get with the 7 times. If you are subtracting this, 283 will get again point 0 we can include here, 2667, which is going to give us a 7 times. So approximately the resistance is going to be 57.7 ohms as a resistance. Okay, now the case 2 B, the next section B. Okay, B section. Power is given, power is 360, voltage is 220. Okay, now current is equal to P by V. 360 divided by 220, cancel 360 divided by 220. No, just division. 36 divided by 22 will give us I. 36 divided by 22. 36 divided by 22 will get 1 times. Normal calculation only I am doing. Okay, you also can do. You will get the exact answer 1.0. Okay, the next one, 22 table 6 times we will try. 6 12 again 13, 132, which is going to give us 6 times. Again 8 will be remaining, 0. So close to this, no, around will get 4. So 22 into 2 4 8 8 88. Okay, so if you want, you can develop the value. You can write here 3 also. Otherwise you can do approximate calculation. 1.63 also correct, 1.64 also correct. Okay, current is equal to 1.64 ampere. The next one, current is equal to, resistance is equal to V by I. What is V? 220. What is I? 1.64. Multiple with 100 numerator and denominator to bring the round number. So 22000 divided by 164. Normal calculation only I am going to do to bring the final answer. So 22000 as a 1 time. Remaining no, 6. It's going to be 6 0. This going to be a 164. No, we'll try with the 3 times. 12 19 4 492, which is going to 3 times. Again this will become 5 10 8 5. This will be 6 1 0 1680. No, the next value will go. Okay, so the answer 134.15 ohms. So R, you can do the similar way of the calculation. Finally you will get what is the resistance. Okay, thank you for watching my video. If you like my channel, please subscribe. If you want more example exercise video, means you can go and see in my playlist. Thank you.